video is probably by far one of my favorite ones because it deals with one of my favorite number patterns. The Hailstone numbers, they are sometimes called, is a very simple number pattern, and yet, as of 2017, this number pattern has not been proven that it works for all integers. So, maybe you guys will have some insight into this pattern. Maybe you'll see some hidden patterns within the pattern that will enable you to unlock this and solve it, and probably win a decent cash prize from, the mathematics community of the world. So let's talk about what Hailstone numbers are. It's just a number pattern that takes you from one integer to another integer. So you start with a positive integer. If the number is even, you're going to divide it by 2. And if it's odd, you're going to multiply it by 3 and then add 1. And then you repeat. You check again. If the answer you get is even, you divide by 2. If it's odd, you're going to multiply it by 3 and add 1. So sometimes the numbers will grow bigger, sometimes the numbers will become smaller. So let's see what happens. And we start with 1. We're going to do a check if the number before is even. I remember there's a test in Excel that will check if something is even. So is even, parentheses, so if this one is even, so if it responds with true, then we're going to do this number divided by 2, comma, otherwise we're going to do this number times 3 and then add 1. So when I hit enter, because it's an odd number, it should respond with the number 4. So let's see if that works. Oh, good. So I built a rule, and now I'm going to drag the rule down. And looks like it's doing a little bit of copying with the same format. I may not want the same format, so if that's the case, if you don't want the same format, you can change this back to no fill. And I have programmed this sheet to specially show you the number 1. So maybe there's something interesting about the number 1. Looks like in this case it's just going to repeat. 1 turns into 4, 4 turns into 2, 2 turns back into 1, and so on. So I think that this one's going to repeat forever. 1, 4, 2, 1, 4, 2, and so on. So I'm no longer interested in the number starting with 1. I think if I start with 2, it's going to be equally uninteresting, but what I wanted to do is show you something. If I click this formula and drag it over, it actually works correctly because if you look up here, this box is referring to the one above it. I just hit escape to get out of that. But if I double click here, this box is referring to the one above it. Everything shifted over. So if I hit escape again and move back over here, notice very carefully this one has E in it. So it's looking at the box in column E. And this one has F. So that's going to be very useful. I know that I was not interested in this because I already knew that 2 turned into 1, 1 turned into 4, and so on. But this is going to come in handy if I want to build my formula over in this direction. And also, I'm going to use a formula to type the number 2. So I want to say this cell is going to equal that number and then plus 1. And so now what I can do is drag this box over and notice that the 2 turned into a 3, and then we have a whole new formula. 3, 10, 5, 16, 8, 4, 2, I know what 2 is going to turn into. It's going to turn into a 1. And the idea here is we can use Excel to build downward, and we can use it to build over with our formulas. That's one of the main things I wanted to show on this tutorial. Of course, 4 immediately jumps into the pattern 4-2-1, 4-2-1. So what about, well, I think 5, we already know what's going to happen with 5 because I see it right here. 5 is going to turn into 16, then 8, then 4-2-1, and that's exactly what it does. Have we seen the number 6 or 7 yet? I don't see either of those numbers on this list. So what I'm going to do is highlight and drag this over twice. So there's 6. Now that one, at first I thought it wasn't going to turn into a 1, but I can see it's about to happen. 4, 2, and if I drag it down again, there's a 1. Now 7's interesting. It's jumping around to all sorts of new numbers that I haven't seen yet. So let's see what happens if I keep going. 40, 20, 10. Oh, there's a 10 up here. And there's a 10 right there, so I know that it's going to go 5, 16, 8, 4, 2, 1. Yeah. So going back to the name of the number pattern, Hailstone numbers. These numbers are called Hailstone numbers because sometimes they float around a little bit, as in an actual hailstone floating around in the clouds, and then eventually it seems like they fall, and they float around a little bit, and then they fall down to the number 1, like a hailstone falls to the earth. So what I invite you to do is to try to build the hailstone number pattern like I did, and then begin to explore a little bit. See if you can find a number that takes, how many did this take? How many rows? So this took 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 numbers. It had to iterate the pattern 16 times before it fell to the number 1. See if you can find a number that takes 10, 20 iterations, 30, 40, and 100 iterations. See if you can use this Excel file as a way to help you explore. You can drag over, remember? You can drag down. And I gotta say, Excel has quite a large number of rows. So it certainly has 100 rows. Maybe try to find a number that takes 1,000 iterations before it falls to the number 1. And if you get lucky enough, maybe you'll find a number that never falls to the number 1. Maybe there's a number out there that dances around in a different loop. Not 4-2-1, 4-2-1, but maybe there's a different loop out there. If you can find that different loop, you just cracked the hailstone problem. Or if you can prove that there is never going to be another loop. In other words, if you can prove that every single integer, positive integer, will eventually fall to the number 4-2-1, 4-2-1, then you also have solved the problem. So there it is, hailstone numbers.